Hi, I'm Cheryl Leach. In this problem, we're given three vertices of a triangle, and we're asked to construct the triangle and then find the area of the region using definite integration. Well, I know how to find the area using a definite integral. I just integrate from a to b and I take the top function minus the bottom function. But to see what region I'm really dealing with, let's go ahead and construct this triangle. So I know that one vertex is 0, 0, and I also have the point 4, 0, and the point 4, 4. Those are the vertices of my triangle. So now I'm going to draw in my triangle. And I want to take a look at what region I've described. Well, let's see. The top function is going to be this line, and it's going to be a line that goes through 2 points. It's going to go through the point 0, 0 and the point 4, 4. Well, I need a function to put in my integral, so I need to come up with the equation of that line. Well, I know how to get the slope of a line. It's the change in y over the change in x. So the slope is 4 minus 0 all over the change in x, which is also 4 minus 0, which means I have a slope of 1. The other thing I need to get the equation of a line is the y-intercept. That was given to me. The y-intercept is at 0. So the equation is going to be y equals 1 times x plus 0. So it's simply the line y equals x. Well, the bottom function is actually going to be the x-axis. So I also am bounded by the x-axis. And again, I need an equation for that. And that's simply going to be y equals 0. All right, so let's fill in some details with my integral now that I have those two functions. I know I'm going to be integrating the top function, which is x, minus the bottom function, which is 0. All right, so let me put in my differential dx, and the only thing missing now are those limits of integration. Over what interval am I integrating? Well, if I look at my picture, I'm going from here to here. So from 0 to 4. There's a vertical line here. You can even think of a vertical line going through at 0 as well, but from 0 to 4. So I can fill that information in as well. Once I do that, I'm ready to integrate. I've got the integral from 0 to 4 of x dx, which is x squared divided by 2, evaluated from 0 to 4, which is going to be 16 over 2 when I plug in the upper limit, and 0 over 2 when I plug in the lower limit, which gives me a total of 8 square units. Now, it's always a good idea, particularly when we have something like a simple geometry problem, to check your results. I have a geometry formula for the area of a triangle, 1/2 the base times the height. Well, the base is 4, the height is 4, so that's 4 times 4 is 16, times 1/2, that's 8. And I got the same answer that I did when I used the definite integral. I hope this is helpful. Thanks.